So, speaking about who we are, I'm Violeta. I'm a digital adoption manager for live events in EMEA. I'm based in Bucharest, and today I'm joined by Amal Raj, who is a technical colleague of mine and who will be your presenter for this session. We have also Sneha in the call that will help us with the Q&A, and Tom, who is my colleague. And will help as well with the Q&A and all the information that you might need from us. All right, that was all from my side. Amaraj, the floor is yours.
Thank you, Violeta.
You're welcome.
Okay, so we are good to go. So hello everyone, welcome once again to Cloud Coaching. I'm Amal Raj. I'm a senior cloud data management specialist here in Oracle. Today we will demonstrate how you can survive a database failure without your application users ever noticing it. So we'll explore the technologies that we need to achieve this, and then followed by a real demo. So the focus is more on the demo part. Of course, we'll go through the techniques and technologies that we need to achieve this. So let's get started. Before we get into the agenda, I want you to imagine what is an ideal availability scenario for you. So for me, like you can see in the meme, I want us to be in a place where DB goes down and nobody should be caring about it. When I say nobody cares, they know for sure that even if a DB goes down, I mean, their applications can continue to run or continue to be available for their end users. So that is an ideal world. Is that really possible? And that is what we are going to explore today. So we will quickly look at these topics today. We will have a look at what is continuous availability versus high availability, how to achieve continuous availability, and how we can mask or how to manage your planned and unplanned outages using application continuity, along with the help of RAC as well as Active Data Guard, ADG. So we'll also identify or help you to identify which solution you can choose. We will also have a look at how does the continuous availability looks in OCI. So most of you might be aware, or you know that the concept of high availability came so many years back, okay, where the focus was on increasing the availability of your critical databases or the uptime of your critical databases. But have you ever thought the high availability of database always translated to high availability of applications? Of course not. Why? Because the HA part of DB was more focused towards the DB side. There was not too much focus on the application side. For example, you had a 2-node cluster, real application cluster database. When one node goes down, yes, the DB instance is available on the second node. But what happens to your application? How it is impacted? What kind of failures or outages the application is having? So this kind of focus was not there with HA. Of course, there was some kind of focus. So HA is really good for DBs. But if you look at from a user experience perspective, it's not that great. And that is how the idea of continuous availability came. So how we can achieve this continuous availability? So that is what we are going to see today. So it's nothing a magic. Okay, you need to have certain best practices on your application, along with some configuration changes, as well as your databases deployed in a maximum availability architecture. So along with all these three, we will be able to achieve continuous availability for our applications. So now I mentioned about MAA. So this term is quite familiar with Oracle database community, whether it is a developer, DBA. So this is nothing but it is a collection of architecture, configuration, and lifecycle best practices and blueprints that Oracle has developed with the kind of experience that we had with customers, with our support requests, the kind of experience customers have shared with us. So this is like a blueprint. It's not just for continuous availability. It's for improving your availability of high availability of your databases. So it caters to a whole lot of things. But with application continuity, what we have done is we have extended the MA architecture to the application side. So we are also covering the application tier now. So what does the application continuity does is it actually masks the outages from the end users and applications by recovering the in-flight transactions. So for the end user, he actually doesn't know there is an outage. He actually feels it as a delayed execution. There will be a slight delay in execution, but he never actually sees the outage or the errors that the DB or the operating system or the server is actually throwing to the application. So that is where the application continuity actually increases the fault tolerance of the systems or application that is dependent on the DB. So this is, again, this is not a brand new concept that has come this year. We have application continuity since Oracle version 12.1, but over the years, we have improved it drastically. Even without too much of application knowledge now, people are able to adopt it and able to implement it. So in today's session, like I said, we don't want to focus too much on the theory part or the concept part. We would like to demonstrate to you how the application continuity works in real life. So we have a system, 2-node system, which we have set up for today's demo purpose. The first node is, as you can see, the node 1. And this is a 2-node rack with the database name as PID_RAC. We have 2 nodes, and the first node name is node 1. This is a scan name. We also have some services created which has application continuity enabled. So no need to worry about this picture. We will have it, see it in action when we are in the console. And the important part is, okay, we are going to do the demo with 2 separate services. The first service is a service called NoAC, which is a service in the DB without any application continuity parameters or attributes enabled. So again, these attributes, we will see it in more detail when we go through the demo. So just you can note down the commit outcome is false, and there are a couple of parameters or attributes I have specified here. So we will have a demo with the NoAC service, followed by we will have a demo, another 2 demo with a service which has application continuity enabled. So there are a couple of attributes again for those services. And also I have started these 2 services, so they are up and running now. So now without too much delay, let us get into the console and see it in action. So if you have been to OCI before, okay, it looks similar. I mean, there is nothing has changed. So the first thing is we can go here, Oracle database. So we have various database solution available, starting with our autonomous, Exadata. So we have, our focus is today is on the VM database, which is Oracle-based database. So we have a couple of DB systems. When I say DB system, these are independent system. Okay, so we will make a use of, we will be using these systems for our demo. So for the first demo, we are going to see how application continuity works with RAC. So I have set up a DB system, and if you look at, we have some basic details here. And when you go to the nodes, yes, you can see this is a 2-node rack, like I mentioned in the slide deck. We have node 1, node 2. These are the details. So this is a view from, from the console. Now, let us bring up a couple of Putty sessions and do an actual demo. Okay, so I have 2 sessions. Both are connected to node 1 of this real application cluster. So I'll explain what we are going to do. I just kept the SQL Plus running because it sometimes throws me out of this Putty session. So the demo consists of, we will have a session connected to one of the service in the DB. Okay, and then we will try to perform an update statement. Okay, and we will not make a commit for that update statement, but then we will simulate either a planned outage or an unplanned outage, and see then what happens with the help of application continuity or without the help of application continuity. So the first one is we will use a service which is not having an application continuity. So I'm in the second window. Let's go to the respective folder which we can use it for today. Okay, so I am in the folder where I have a couple of scripts. Okay, for the purpose of this demo, I made a couple of scripts. Of course, I can explain you that. So the first one is, let us see the attributes of the service. So this is what I was telling in the slide. The service name is NoAC, and this service will be running when the role of the database is primary. So there are too many other attributes, but the focus for today is to understand the attributes for application continuity. So there are a couple of things like commit outcome, failover type, failover restore, and of course this is only running on one instance now. Okay, you can have it running on both the instances, that is fine. But for the purpose of this demo, this is running only on one instance, which is the node which we are logged in. So we know these attributes, it's good. Second one is we will see where the service is currently running. So the service is currently running on PRD1. So PRD1 is nowhere else. We are in the same node, if you can see here. So this is the node the service is running. So we know where the service is running. So these things are important because when we do the simulation, it makes sense. The next thing is we want to make a connection to this particular service. Okay, so when I say the service, as we had seen previously, this service is connecting to one of the PDB, which is sales PDB, and it is running on PRD1. So I am going to use a connection string like this, okay, where I have mentioned the service name as NoAC, and there are a couple of other things. The scan name is here, and of course there are some recommended parameters here. Okay, so we are going to use this particular script to connect to the service, and the next step is I will go to the same kind of same directory structure here, and then I'll try to connect to the service. So I'm using a shell script. Okay, I've connected to the SQL plus. So how this is connected, it is using these statements. Okay, nothing else. So now we are connected to we have a session which is using a NoAC service. What that service attributes we have seen. Next step is we want to see the information about this particular session. So we are here. Let's see. Let's try to get some information about this session. Okay, so the session on the first window has these values. It is connected to instance 1. This is the SID. Username is this one because as you can see, we are connecting as HR user. We are using service name as NoAC. Failover type is none because this is a no application continuity enabled service. So we haven't enabled any failover, and failed over is no, which means this is a brand new session. Nothing has happened to any instance where it is connected. Now, next step is we want to make an update statement. Okay, so let's see what is session info we had seen. Let's try to make an update statement from here. Okay, that update is maybe used. So I'll use the second one. So what I have done is I have made an update to one particular table. One row has been updated. Now I will not do the commit now. Instead, I'll come back here. And we want to simulate a planned outage and see what happens. So the next step is we will relocate this NoAC service from the node 1 to node 2. We know that this is currently running in node 1. That's why we had seen earlier with the status command. Yes, this is running on PRD1. So we are in node 1. And this particular shell script, it is just invoking an srvctl command. So this is a command in case you have a planned maintenance. We use similar commands depending on the situation, of course. So we use the relocate command. So what it does is it relocates my service, which is NoAC, from my current instance to a new instance. Okay, with a drain timeout. So I'll invoke this. Okay, so I have done a relocation. Now just to understand where it has gone now, I'll see the status again. And now you can see my service is on PRD2, which is on node 2. We are in node 1. So service has been relocated, but we will give it some more time because I just want to elapse this drain timeout. So basically the draining happens, okay, throughout the window. So when I say, when we did the relocation, we had specified a drain timeout of 30 seconds. This can be much longer in a real case scenario, but I just put this at 30 seconds. So what it does is whatever connections it can drain, which means that connections are not active or the work it was doing is done. So we are giving some timeout for the active transactions or active sessions to complete. In case it is not complete within 30 seconds, that is when application continuity comes into help. So it can fail over those sessions where the work is not completed or it is unable to drain. Then application continuity kicks in and helps you to fail over. So now I think almost like 30 seconds might have been done. Yes, it is over. I'll come back to the first session and try to do a commit. Okay. So this is expected because we haven't had any application continuity enabled in this service. That is why your session which was connected to node 1 is lost. This session is no longer there because your service has been failed over and 30 seconds are over. So there is no application continuity. So your service was unable to fail over. So now this is a scenario that most probably, anybody will have if they are not using application continuity. But the real purpose of today is how application continuity can help you in these kind of situations. So now we are done with no AC or no AC service. Let us go to a second scenario where we will have the same steps done, but using a different service. That service is having application continuity enabled. Okay, so now similar to the previous demo, we will just have a look at the attributes of the service. Okay, so you can see the service name is AC, the service role is primary, and these are the couple of things I was discussing in the slide as well as in the previous demo. These are the things which actually defines application continuity. Commit outcome is true, and then failover type is transaction. Failover restore is level 1. So these define this is enabled. This service is having application continuity enabled. On top of it, I also specified replay initiation time and drain timeout. I will again explain this once I done with the demo. Again, this is running only on first instance. Second instance, it will go in case there is a failure in the first instance or there is a planned outage. Second one is we are going to use the status command just to see where the service is currently running. So as you can see, it is currently running on PRD1, which is our current instance. And similar to the previous no AC service, I am going to use a similar connect string. Only difference is instead of the service name no AC, we are now using AC service name. First, everything remains the same. So now we have everything ready. Let's have a connection to the AC service. So I have connected to an AC service. But to understand where it is connected, what we will do, similar to what we have done earlier, we will see the session information. Okay, so this is the session information for the session which is connected from the first window. It is connected to instance ID 1 because your service is running on the first instance. And now instead of no AC, it is connected to AC because we are connecting to an AC service. Failover type is not none because this is an application continuity enabled service. So failover type is transactional. And this is same thing we have seen here. Failed over is no, because this is a new session. Nothing has been failed over yet. The next step is we want to perform an update. Okay, so we have performed an update. We will not commit it now. Similar to what we have done earlier, we want to relocate this service from node 1 to 2. I think I have made it 2 to 1. Let me see, I have the command for 1 to 2. Okay, yeah. I'll just, we have done before, I'll just show you what is the content of this. So similar to the previous one, I am relocating the AC service from old instance to new instance. Currently it is on instance 1. So let us execute this command. We are relocating from 1 to 2. I'll just see the timing. Next step is, again, we want to see whether it has been relocated. Yes, instead of running in node 1, it is relocated to node 2 now. But like I mentioned, let's wait for 30 seconds because that is when the application continuity can actually kick in for the active sessions. Otherwise, 20 seconds. Okay. So we'll wait another couple of seconds, and then what we will do is we will come back to the first window and try to issue an update state, commit statement and see. So we are good. We are more than 30 seconds. I'm coming back to the first window. I just did a commit. Okay, it got completed. So what has actually happened? Okay, even though we failed over the service or relocated the service to node 2, let us understand what happened to our session. So now you can see there is a session in node 2. The SID has been changed, okay, and service name. But if you see, the failed over has been made as yes. So this is the same session which was in the node 1. Due to our planned maintenance, it has been failed over to node 2 with the help of AC. So this is the beauty of AC with application continuity. You are able to move your active sessions. You are able to continue your in-flight sessions. We had an update which we didn't commit, but with the help of application continuity, you are able to continue that session in the failed over node. So this is how, it helps to improve the application experience from a user perspective. So I have taken SQL Plus here, but it's not a very good client if I want to demonstrate this, but for the simplicity, I have taken it. But if you compare with an actual client, all the outages, the previous errors that we have seen on the SQL Plus, everything is hidden. Even though you lost this session, you are able to continue without any errors thrown to the end user. So now this is good in terms of planned outage. Okay, planned outages are, this is really good. Okay, if you want to hide the planned outage. But what happens? Okay, sometimes you cannot always plan anything. Sometimes unplanned things happen. And then let's see how application continuity reacts or how application continuity acts at that and on that scenario. So the third scenario is we are going to have the same thing, but we will simulate a unplanned outage. Instead of relocation, we will simulate an unplanned outage. So we have seen the attributes. I am not going, nothing is changing. We are going to use the same commands. Only thing is how we are making the outage. So I'll make a connection to the AC service. For our interest, we will also see what is the session information is like. Okay, so we are connected to the first session. This session is actually connected with these attributes. Okay, which is good. We'll come back to the first node and make an update statement. Okay, and we'll keep it as it is. We don't want to touch there. Okay, that session, let it be there. Now we want to see where the service is running. Of course, the service it has been changed now. Okay, the service has been moved to PRD2. Okay, so I'll just, we will have it slightly peak this because I have node 1 window open. So I just want to relocate this and then have a correct command. Currently it is on PRD2. Since I have the node 1 windows open, I don't want to again connect and then spend some time in connecting to node 2. So I'm going to relocate from 2 to 1. Otherwise, this is really not required. We'll again see the status. Okay, this is on PRD1. So I will not use this session. Why means, yeah, there are some errors came. So I will not use this session. Why means because I wanted to continue with the node 1. So we will clear everything. We will have now we have a connection, and that connection should be on node 1. Only I made a relocation just because I want to continue with the same window. Okay, so we have a good scenario now. We have connected to AC, and we can see it from here. It is connected to instance 1 with transaction and failover as no. Next thing is we want to make an update statement. Okay, that update we had used it. So I'll use the second one. Okay, so one update has been done. Now, how do we simulate a unplanned outage? So the best thing is we will kill the session. We will kill the smon. So smon, those who are not aware, this is a background process for the DB. So I'm going to bring down the DB by killing the smon. Kill -9. Okay, this is the smon of PRD1. This is for ASM. So I'm going to kill it. I hope, yeah. So the DB is down now. As you can see, okay, there is no smon for PRD1. So the DB is down now. Now here there is no draining, no concern because your DB is down. Okay, there is no time for any draining. But what I want to do, in the first window, we were connected to the instance 1. I want to come here and do a commit and see what happens. See, the commit is completed. So what has happened? Even though you made your DB down, the commit is able to complete. So again, let us go back to the CDB. Okay. Okay, I will not be able to have a session for, yeah, okay, this is fine, yeah. Okay, so what has happened is the session which was connected on node 1, which is now failed over. So the last column is for failed over. It was not failed over, but when we kill the SMON, it has been failed over to the available instance. So this is again, I would say, really helpful in case of, because nobody can do anything in case of an unplanned outage. But this is like an ideal scenario. Even if something goes down, that's what in the meme I was telling, your node 1 goes down, people are not worried because you know for sure your DB is able to fail over and continue your transactions over there. So now it's good. Okay, we are able to cover all the 3 scenarios related to real application clusters. Now let us come back to our slide. Yeah, we just finished this demo. So the next one is we want to see how does application continuity helps in case of an active data guard. So I have set up these systems. We have a primary node, node A, and it is in maximum availability with another node. This is our standby node, node B, and this is node A scan, node B scan. We also have a data guard broker for observer that is to help us in case of an unplanned outage. So again, no need to worry about this picture. We will have it really see it in action when you do the demo. Similar to the RAC, I have made a service. So here we are not going to try the demo with the no AC because everybody knows what happens if there is no application continuity. It is going to fail. So we are going to see 2 scenarios, a planned scenario as well as an unplanned scenario with application continuity enabled service. So when we have it in primary, which is already started, in standby, this is not started because this service will come up automatically when standby assumes the role of primary. So now we will have a demo. So let us go back to the Putty sessions. So give me a few seconds before I bring up the Putty session because whatever I have brought up, it has been timed out. So we'll have to couple of Putty sessions. I'll bring it up. So we will have one Putty session connected to node A, which is our primary node. Okay, another one also for node A. Then we will have one session for node B and one for our observer. So just for node B, the color is slightly different. Okay, so we have everything ready here. I'll explain the console part. How does it looks like in our console in a bit. Oh, we are already in Oracle. Okay, so I'm just okay, good. Okay, so I'll explain the console part maybe because that will help you. Okay, so before, yeah. So we were using the AC and RAC system, this one for our application continuity. Now for the next demo, we will have 3 systems. One is CCA, this is our primary node. This is a standby node, and this is our observer. Again, the details of these things, before I initiate the switchover, I'll again explain. So let us come back here. Just give me a second. I'll just bring up that blue one also. Okay, good. So now we have all the sessions ready. We will have a first demo is on the planned outage. So like we had seen in the application continuity with RAC, let me go to the correct folder. Okay. So the first step is we will see the attributes of the application continuity enabled service. Again, similar thing we had seen it in our earlier RAC session. Only thing is here we have only one preferred instance. It is not a 2-node rack, only one node on the primary, and available instance is nothing. And you can see your commit outcome is true, failover type is transaction, and failover restore is level 1. So we have our application continuity enabled services, and we will also see where it is currently running. So currently this is running on primary, which is a prod. We will also have a look at whether it is running on the standby. Okay. So in standby, it is not running. Why? Because it will only come up when the role is primary. So if you check the attributes of the service here, it can only come up when the role of the database is primary. So currently it is standby role, so that is why it is not up and running. So now we have seen two things. Next thing is we are going to use a connection string like this. And I'll also show you how does this TNS looks like. So we are using a TNS alias like this, where we have specified the service name. I also specified the scan IP of primary. This is actually on the standby. Also the scan IP of primary. So we are actually specifying both primary and standby scan IPs, as well as a couple of other parameters here with like failover 1. So we will get connected to this one from the node 1. I'm going to connect to AC. We have a connection established for the AC service. And the next part is, as always, we will see what is the information about that session. So this is the information about the session, which is connected from the first window. We have an HR user connected as SID. Transaction is a failover type. It is not failed over. It is connected from the machine node A, which is our primary node. Now the next step is we want to perform an update. Let's try to perform an update. Okay, I think that update has been used, so no problem. We have another update. So we have performed an update. Now we want to see what happens to this if you perform a switchover, which is a planned outage. So for performing the switchover, we will go to the console. But before that, I wanted to show something. Okay, let us, I hope it doesn't time out or something. So sometimes, okay, yeah, it's fine. I will just connect it. Load_A. So now my observer is a piece of software that observes both your primary as well as your DR. So currently the observer is down. I'll start it. Okay, we will have another session for this just to see the. So what I was mentioning is observer is a piece of software which is actually monitoring both your primary and standby. And it is helpful in case of a failover. When your primary goes down, observer can actually take over and do the failover and make your standby as primary. So again, we will go here and I'll just want to show you how does it looks like, the configuration from. Okay, so now you can see previously we had some errors. Now it is in protected mode, maximum availability. Primary database is our node A, which is running on node 1. And then physical standby is on this one. So fast start failover is enabled. Configuration set is success. Now to simulate a planned failover, as I was mentioning, we will go back to the console. So we are in the console. I am in the primary node. I'll explain these things before once the failover switchover has been initiated because it takes some time. So I'm in the Pro DB. We'll go to the DG association and we will initiate a switchover. I'll just come back and here because just want to see our commit. Yeah, Pro has been updated. Okay, good. So we'll perform a switchover. Okay, and if you want to see the work request, okay, you can come here. So like the previous switchovers has taken 2 minutes. So while it is taking the time, I'll come back and explain what is happening from here. First place we want to go is we will go to the observer and see the observer log. We'll keep it open. Okay. Yeah, so let it be there. Meanwhile, I'll just explain you how does it looks like. So in the DB system, when you come to the DB section, you can go to DG association and here you will see all the information related to your data card. So you can see the peer system is CCB and it is in standby role, maximum availability. It is in an ADG configuration. So similar information you can get if you go to the CCA system, CCB system. You can go to the DB, DG associations. You can see the peer DB system is CCA. So now we just performed a switchover from CCA to B. We'll go back to CCA and go to the work request. We'll wait until this is completed. But meanwhile, we can come back and see what is happening on the observer. So if you look at the observer, okay, we were doing a switchover. That's why the primary was unable to connect. Now the new primary has been changed to prod underscore this. So why this has happened? Because we initiated a switchover. So from an observer log, it is like almost complete, but on the front end, it is slightly taking more time because there will be some couple of additional checks. So actually the switchover has been done in the backend, but we are just waiting for to happen it on the front end. So I'll just bring up all the two windows ready. Once this has turned green, we can continue. So meanwhile, if we are interested, I can show you some related information in the DB system. So when you come to the OCI, this is the information you can see about your database, the availability domain, your CPU count, your whatever is related to whatever provision in terms of provisioning, whatever you have selected, you can see host name and the scan name. So there are a whole lot of things, a whole lot of information related to your DB system and which node it is, and if it has a public IP or private IP, what for domain, and whatever work has been done in the past. Okay, so you can see whether it's start node or stop node. So we'll come back to DB. I think it is taking a little bit more time. Yeah. So let us go back to the observer and see anything is happening there. Nothing. So we'll wait a couple of seconds. I could have opened alert log, but okay, let's see whether I can open an alert log. Okay, so I am in node A. Okay, it's not working. Looks like the alias is not working. That's fine. Let us come back and here and see what is happening here. Okay, still taking time, so no problem. We will wait. There is no new messages from your observer log because, like I mentioned, it has been done. So good that our switchover has been completed now. Like I mentioned, it has taken slightly over 2 minutes. Started at 9:44 and 9:47. So now switchover has been completed. The next part is we want to come back to our node A and try to do a commit. Okay, so the commit is complete. So what has happened? Okay, we were in the DB was a primary role in node A. We did a switchover. Even after the switchover, you come back and do a commit, it is done. So what has happened is, to understand what has happened, we need to go to node B because there is no session running in node A now. Let's go to node B and see if we have any session there. Okay, so we see one session there, which is actually the session which was connected from the node A. This is the machine name of the session from where it was connected. So as you can see, we were connected from node A, and the failover was actually no. If you could see somewhere here, failover was no. Now it has been turned yes, because from node A, this particular session has been failed over to node B because we had done a switchover from the console. Now again, this illustrates how you can survive or hide your database outage with ADG in case of a planned scenario. Now the next or the last demo for today is we will see how ADG behaves when there is an unplanned outage. So let us clear up everything. I mean, we will need two more sessions for one more session for node B, because now the primary node is node B. So I will have one more session for node B. Okay, that's good. And node A, we only need one session because most of the work we will do it from the node B. Okay. We also have something for node A, and I need one for my observer. Okay, so again, we are ready with our windows or terminals. So again, I'll connect, I'll have a connection. Initially, we will see where is the service running. Now we have done a switchover. So now the service is running on node B. If you come back and do it in from here, you will find it, the service is not running because now this is in the role of standby. So service is not running in node A, service is running on node B. Now, as usual, we want to have a connection to the service. We have made a connection to the service. We will see the attributes or the information about the service. I'm not in the correct directory. Just bring it up. Okay, so we have a connection which is from the first window. It has been connected from the node B because this is running from the same DB node, and these are the information. Next step is we want to make an update statement. Okay, now so the update statement, we will leave it as it is. We will not disturb this one. So we have seen a planned scenario. Now the next one is we want to have an unplanned scenario or an unplanned outage. So for that, what we'll do, like we have done for RAC, we can either bring it down. So instead of kill, what we'll do today is we will use an srvctl command and abort it. So we are going to use this command and then see what happens. So I'll use sh7 fail.sh. Okay, so I have initiated a failover because I am going to stop it with abort. Now the best way to observe this is from the observer log. Like I was mentioning, the observer will come into action in case of a unplanned outage, where it can act on our behalf if we want to fail over and bring our standby as primary. So it will take some time. Okay, we will wait for a couple of seconds because this statement is still executing. Okay, yeah. So now we can see the DB has gone down. Grab S1 if you see. Okay, there is no database running here on node B. And it is also evident from the observer log. See, it is unable to connect to the primary DB. This was our primary DB. So it keeps trying. Okay, it's not like the DB down and the next second it can fail over to initiate the failover. So there is of course thresholds in terms of fast start failover. Okay. Now, since it is unable to connect after that threshold, it is now trying to do the failover now, which means it is now trying to make our node A as primary. Node A was in the role of standby. Because of the failure in node B, unplanned outage, your observist has taken over the situation and it is now performing a failover. So we will wait for this, and then once the failover has been done, I will come back and do an update statement here and then see what happens. So now we can see, yeah, first out failover has been finished. Okay, failover has been succeeded. The new primary database is prod A, but it'll keep trying to reach the old primary, which it cannot, because since we have done an abort, the clusterware will not try to bring it up. So it remains in the down state. We'll have to manually bring it up, because in an ideal failover, okay, you don't want your failover session to come back again unless everything has been fixed. So there is some issue here. Assume that there is some issue here which we need to fix and then bring it back. So now we have our available database in prod A, which is our new primary. Okay, let us come back and do a commit here. See, the commit is complete. So again, try to understand, okay? I'll explain once again. The first thing is we want to check the session information. So the session we had from node B, that has been failed over with the help of application continuity to the node A. Now the service or the primary DB is in node A. Node B, as you can see, it is still down. But see the beauty, you are doing some transaction in node A, node B, which was primary, which failed, or we simulated the failure, but you are able to continue a transaction in node A. So this is how application continuity helps you to hide the outage. There is an actual outage, planned or unplanned, but the end user, the actual end user is not even aware. He is able to continue with his work. So that is in terms of the demos that we wanted to cover today. Let us go back to the slide. So this is the demo that we just completed. Now, I know for sure most of you will have confusions about whether to use application continuity or we should use TAC or TAF. So basically the recommendation is to use TAC, transparent application continuity, with draining, because it can handle a lot of things. Even if you don't know how application is implemented, you don't have connection pools. So many things TAC can take care, but of course it has certain limitations. If you have some side effects, like your application is performing something outside of DB, or within DB it is invoking something and doing a file transfer. So if you want to have that side effects to be included, yes, TAC cannot be used, because TAC by default disables that side effects. So this is just to give you an idea, just a starting point. Of course, there are too many things involved in deciding what is best, and there are too many checks you can do. There is something called application continuity health check, ACC check, which will help you to identify at what point how many sessions can be actually failed over, which are not failed over. So there are so many tools which can be of great help in terms of deciding this. But irrespective of the solution, always it is recommended to have the draining, because draining means you are giving some time for your active sessions to complete, and whatever is not completed within that time, we are actually trying to recover or fail over with the help of continuous availability, application continuity. Now, what is the difference in OCI? So whatever we were discussing till now, it is actually related to the co-managed database. When I say co-managed database, the Oracle-based database, Oracle Exadata Cloud Service, or Exadata database dedicated, all these are co-managed along with the customer. For those, yes, we need to take these services, you need to change the attributes of the services, so you need to do a little bit of work. But when it comes to autonomous shared, by default application continuity is disabled. There is a PL/SQL package which you can use it to enable application continuity. But in terms of autonomous database dedicated, by default TAC is enabled. So for autonomous, we always suggest we have by default 5 services available for our transaction processing DBs, which is TP urgent, TP. These 5 services are by default created. These services are not just for application continuity. These are the services which determines your parallelism, your priority. Whole lot of stuff is actually transparent for the user. They just use the service, whatever they need. So basically the recommendation is, okay, to use TP urgent and TP even in for shared. To enable, if you want to enable application continuity, enable it basically for TP urgent and TP. Of course, you can do it for these things, but we don't recommend, but because these are more related to your batch operations, okay, for which it won't make much sense to enable application continuity because those are very long sessions. But of course, if you wish, you can do it. So I think, yeah, that's what we wanted to cover it for today, along with some demos and some concepts. Hope it was clear to you. In case there are Q&A, I think we can take it up now.
And Amalraj has added for you some useful links related to the surveys that we have covered today. Keep in mind that we are going to share this presentation on the public Slack channel that we have mentioned at the beginning of the session. Any questions to cover? I see that Sneha already answered tons of them. So I see no open questions, right?
Yeah, I think we are covered.
All right.
Thank you, Sneha.
Thank you, Sneha, for all the help today. If no further questions, then I would kindly invite you to book your boost call with Amalraj in case you would like to discuss more on the subject. And of course, to thank you all for attending the session, to say a big thank you to Sneha and Amalraj for being here and presenting to us. And of course, we are waiting you on upcoming events. I see one. I would like to have additional test case using application web server. Okay, and Sneha is already answering this question. All right. Okay, good. Don't forget, you can always reach out to us on public Slack on under the Cloud Coaching channel. All right, thank you all for attending. Have a great day and hope to see you soon. Bye-bye.
Bye, thank you.